Welcome to the lecture series of Embedded System and Programming. In this series, we are going to discuss about the microprocessor architecture. So in the previous series, we have discussed about the basic fundamentals of ALU and the difference between the microprocessor and microcontroller. So in this series, we are going to study about the in-depth of the microprocessor architecture. As before going to the application of a microprocessor, we will discuss about the basic components like, as we know, it has an arithmetic logic unit which performs the arithmetic and logical operations, and main thing is a control unit, that is CU, which directs the operations of the processor by fetching, decoding and executing. So these three are the controlling unit functions, that is fetching, decoding and execution. And coming to the registers part, it is a small fast storage locations within the CPU for temporary data storage. So it does not have the inbuilt memory and inbuilt registers. It has an 8-bit register to just store the immediate respondent of the accumulator, program counter and stack pointer. Next, coming to the instruction decoder, interrupts instructions fetched from the memory. And next is bus interface unit, manages communication within external memory and input-output devices via address, data and control buses. And next is types of microprocessor architecture. So basically, coming before to the Intel processor, we can discuss about the basic type like von Neumann architecture. It is a single memory for both data and instructions. Simpler design but slower due to its shared bus, that is bottleneck style, and that is a basic database for the Intel 8085. So coming to the hardware architecture, it has separate memories for data and instructions, faster execution due to the parallel access to data and instructions. An example, many microcontrollers, we can take it as PIC microcontroller, AVR, etc. So we know about the RISC and CISC. RISC is nothing but reduced instruction set computing, whereas CISC stands for complex instruction set computing. So the main difference is RISC is simple. It has simple instructions, faster execution, fewer clock cycles. Whereas in CISC we have complex instructions, more versatile but slower. And we can take Intel 8086 for the CISC architecture. So we are taking another example of Intel 8086 microprocessor, and this is a 16-bit microprocessor and it has 20-bit address bus. Registers we have AX, BX, CX, DX. It is a general purpose, and apart from the registers we have the SI, DI, BP, SP, that is index and pointer, and segment registers like CS, DS, SS, ES, and instruction set which includes the arithmetic, logical, data and control instructions. So coming to the architecture of 8086, that is Intel 8086 microprocessor, here you can see first of all we have the ALU, that is arithmetic logic unit, and which is connected with the control system, and above the control system we have an instruction stream byte queue, and this is the most special in 8086 as it has a pipelining system, that is it can store up to 6 instructions, 6 upcoming sequence instructions, and it helps in avoiding the delay of the instruction fetching process. And this is the most uniqueness and difference between the 8085 and 8086. And next, coming to that, we have discussed, like we have segment registers like ES, CS, SS and DS, and we have the two basic division like is bus interface unit and execution unit. So in the bus interface unit we can find the registers, and in the execution unit you can find two main unit like control system and arithmetic logic operands. And apart from that, yes, we have flags and operands to state the instruction state and the output execution state. And apart from that, we have 8-bit, that is combination of 8-bit, we have 16-bit, that is AH, AL, and from A to D we have the 4 types of registers, which is all 4-bit registers, sorry 8-bit registers. And apart from them we have stack pointer and stack instructions like that. So coming to 8086, the whole architecture is inbuilt in a single chip, and the single chip configuration is also discussed here. You can see we have the four input output pins. So starting from, as we discussed earlier, we have 20 address data bus. So we can see starting from the ground, it is given to the 20th pin and VCC to the 40th pin, and this AD is nothing but the AD stands for address data bus, and S1, S2, S0 is nothing but the signal status, and we have the hold signal to uh, indicate the instructions to hold for a while, and hold acknowledgement is acknowledging that it is ready to perform next. And we have write and operation, read operation, memory, that is nothing but it states whether the port, the Intel processor has to act as a memory or input output port. And apart from that, we have the address latch enable options, interrupts options. Yes, it is the most important thing. We have an interrupt here, interrupt in here, and non-maskable interrupt here. And we will discuss these interrupt concepts in a later in the lecture series. And these are the main pins, as we have read option here, and lock, maximum mode and min mode. So these are the control pins where the previous architecture is compressed and configured into a 40 pins. So in the next upcoming lecture series, we will discuss about the microcontroller, and then we have a comparison of both. Thank you.